Legacy Savers, welcome to Chapter 3. Today we're going to look at Section 3.1, which is on inequalities and graphs. Please make sure you have your notebook with you and also a pencil. You do not need a calculator today. So what's the video going to focus on? This video is going to focus on how to write, graph, and identify solutions of inequalities. So we were just focusing on equations the last chapter. Today, this chapter is mostly on inequalities. So the symbols that you need to be aware of. And a lot of you know about these symbols already. You just have never, I just want to make sure we all know them before we start talking about them. So the symbol for less than is an arrow that points to the left. So that is how you write the word for less than. So it's the shorthand. Greater than is always an arrow that's pointing to the right. Less than or equal to is the word is less than, but then it has a little line underneath it if you remember. And then greater than or equal to is an arrow pointing to the right. So make sure these get down in your notebook, especially if you have a lot of trouble identifying them, because we're going to be using them consistently throughout this chapter. So this first problem, they give you an English statement and we need to transfer this to math essentially. So they say all real numbers x less than or equal to -7. So all real numbers x, so I know that x, and then they say less than or equal to. So if I look under my little list, I remember that that is an arrow pointing to the left with a line underneath. And then they say -7. So x needs to be less than -7. So that one is actually done. All I need to do is write them. Now they want us to also do 6 less than a number k is greater than 13. So less than, if you notice, it doesn't have an x with it. It has the 6. So actually that is meaning, right here, this is meaning subtraction. It's not the less than symbol. So they say 6 less than a number k. So that must be k minus 6. And then that it is greater than, so that is an arrow pointing to the right, 13. So k minus 6 is greater than 13. Let's take a look at a few more of these. All real numbers p greater than or equal to 1.5. So all real numbers p, so p greater than or equal to 1.5. So p is greater than or equal to 1.5. Last one of these kind. The sum of t and 7 is less than -3. So I have t and 7, and sum. If you remember back from our first chapter, this was adding. So we have t plus 7 is less than. So less than is an arrow pointing to the left, -3. So the next thing we want to talk about are what solutions. So if you remember, we did a solution of equation during chapter 1. I think it was chapter 1. So a solution to any inequality is any number that makes the inequality true. So if I plug in the number, I should get a true statement back out. So let's take a look at a few of these. They say, is the number a solution of 2x plus 1 greater than -3? And they ask, is -3 a solution? So what I'm going to do is I'm going to plug that in for x. So I'm going to go 2 times -3 plus 1 is greater than -3. So now I need to generate what this is over here. I'm going to simplify. So 2 times -3 is going to give me a -6. And I have -6 plus 1. It's a -5. So then I have to ask myself, is -5 greater than -3? No, it's not, right? So no, it is not a solution. But let's try -1. So I'm going to do the same thing as I did over there, but with -1. 2 times -1 is -2. And -2 plus 1 is -1. So then I got to ask myself, is -1 greater than -3? Yeah, it is. So that is yes. It is a solution. Now, we are also going to graph these. So, to graph an inequality, these kind especially, we're going to use a number line. If you guys remember, you guys have used number lines. They look like this. They have a bunch of little numbers laying on here. Usually they're numbered by 1. Stuff like that. So, we're going to do 2 parts to it. First of all, we need to put a dot on the number. So, if I would have 4 for my number, I need to put a dot. So either I'm going to use a closed dot, which is basically a filled in dot, so it looks similar to this. Or I can use an open dot, which is a dot that looks like that. So if you notice, it's open. It's not filled in. A closed dot is referenced when I have the equal to underneath of my inequality symbols. So I like to remember that there's 2 parts to this symbol. So there needs to be 2 parts to my dot. So on the other hand, for open dot, I can have a less than and a greater than. Notice how there's no lines underneath, just less than and greater than. And then we need to shade in the way of that. So if I would have x is less than 4, I would put an open dot on 4, like that. And then I need the numbers less than 4. So I need to ask myself, is 3 less than 4 or is 5 less than 4? 3 must be. So I need to show somehow that this way is the correct way. So a lot of people will go just like this. They'll just put an arrow going that way. Some people will put the arrow actually on the number line. I will normally go like this. And I will shade that side. I will actually like color in and scribble in the way that it works. Now, there's a really cool way to know which way to shade. If you notice, I shaded to the left and my arrow is pointing to the left. That's pretty cool, right? But you can follow the arrow. But the variable has to be on the left. So if we ever have a variable on the right, so if this would look like this, I can't follow this arrow because it's not going to be the right. These are actually the same statement, just flipped around. So if I ever come across one of these, I want to flip it so I see my x on my left. That is easier for me to graph. So make sure you pay attention to see if your variable is on the left, and then you can just follow the inequality arrow. So let's graph a few of these. They say graph 2 is greater than or equal to a. So just like I was saying, I want to make sure that my variable is on the left. So I'm going to transfer this around. A, and it looks like the arrow has to be pointing at A, so I'm going to make sure my arrow is pointing at A. And then 2. So A is less than or equal to 2. So on your notebook, you are going to want to draw a number line, and I'm going to label it. Now, you do not have to fill in every single one of these spaces with a number. I'm going to fill in about 5. So I'm going to start right in the middle. I'm going to put 2, which is the number I have. And then around 2, I'm going to put the numbers around him. Kind of leave some room around there. I don't have to put everything. You can if you want to label everybody, but as long as you have 2 and a few others, you're okay. So then I need to ask myself, what kind of dot am I going to have at 2? So I'm going to look at the inequality sign. Since it has a less than or equal to, I'm going to use a closed dot. At 2. This pen does really not like my closed dot. There we go. So I have a closed dot at 2. So now I need to ask myself, where are my a's, or my numbers, less than or equal to 2? And since my variable is on the left, I can follow my arrow. So I know it's that way. Let's try this one. X is greater than -4. So I need to put my numbers around. Now, make sure that you put the ones less than -4 on the left. So that's -5 and -6. And then -3, -2. So what kind of dot at -4? I should have an open dot because it's only greater than, not greater than or equal to. So I get to have just an open circle around there. And then I need to ask myself, where are my numbers greater than -4? And since my arrow or my variable is on the left, I can pull and shade to the right. Now they want C is less than 0. So I'm going to put 0 in the middle. -1, -2, -3. Whoa. Miss Marsh can't count. One, 2. There. Now I can count. So now, look at my sign. I'm going to have an open dot at 0. And I know that I need to shade to the left. Now, the next kind of problem is when they give you the graph and you need to be able to write the inequality that they give you. So I'm going to first write x, because I can use any variable. I'm just going to use x. And then I know the dot's at -1. So I have x and -1. Now I need to see which way is my arrow going to point. Now since I'm shading to the right, I know my arrow is going to point that way. And now what kind of dot do I have? It looks like it's a closed dot. It's filled in. So I need to have a line underneath. So I will have x is greater than or equal to -1. So over here we're going to do the same thing. Got x and 4. Now I need to ask myself, which way am I shading? Left or right? And it looks like I'm going to the left, so I'll make sure my arrow goes to the left. Then I need to see, what kind of dot do I have? And it looks like it's open, so I do not have a line underneath. So I have the answer of x is less than 4. Last ones for the night. So problem 6 is on real-life applications. You see a lot of inequalities everywhere. One thing that you see is restaurants can seat at most 172 people. So this is for fire code reasons. You can only have 172 people safely in this building. So I need to be able to write the inequality. So I'm going to have x and 172. Now, at most, does that mean that I can have 173 people? No, I can't have, that doesn't mean that. So I need to have something less than 172. But can I have 172 people on the dot? It seems so. So I should have x is less than or equal to 172. Now, a person must be at least 35 years old to be elected president of the U.S. That's actually in the Constitution. So x and 35. Now, can the person be 20 years old and be the president? No. Can they be 50 and be the president? Yeah. So x can be greater than 35. So at least means greater, and also they can be 35 right on the dot. So x is greater than or equal to 35. And the last one, you must be at least 18 to vote in an election. So x and 18. So at least. So you guys are about 14, 15. Can you vote? No, you can't vote. So x cannot be less than. So we need to use greater than. And at 18, I can vote. So x can be greater than or equal to 18. That's the end of the video. Have a good night.